Welcome everybody to our June, I nearly said May, but it's already June, our June Clinical AI Interest Group meeting. Um, we have a wonderful speaker today, Mirella Lapata, who's here, who Joe will be introducing in a bit. I'm just going to start by doing a few introductions to some things that are going on in our space, because one of the first things I want to do is, oh, please stay muted. Just reminding everyone to stay muted. Um, one of the things I'm going to do is apologize. Oh dear. I'm just going through and muting people.
Before that, I took a big.
Hold on. There we go. There we go. That's better. So a reminder just to stay muted, because otherwise we can hear all your background noise, and your conversations will be on our video, which you probably don't want them to be on there. I'm just going to say a bit of an apology because I haven't actually sent out a newsletter this month. It's on my to-do list and actually in my draft emails at the moment. So I thought I would start the meeting by advertising a few events that I think you might be interested in, because that's usually what we do in our newsletter. So one event that actually was last week, and I saw some of you at this event, was our AI for Women's Health first conference, which happened in Cambridge last week. I can see Rhonda because she was there. Hello, Rhonda. It was really a great day. What I really loved about it was that we had a real mix of people. So we had people who were social scientists, we had data scientists, we had clinical researchers, we even had patients there as well, and we had some different we had different talks, but we also had lots of panels where we had some really great discussions about things like patient involvement in research. We also had a really interesting panel on bringing in social science approaches into the kind of AI and women's health area, which I really enjoyed that one particularly. And we also had some panels that had quite technical discussions around data, because data particularly is one of the real issues with doing women's health research, particularly in the AI space, like how much data you can get, whether it's biased, and all of those different issues. So that was really interesting. We will have some videos coming out from that particular event, so watch out for those videos because we'll advertise them through the newsletter. There's two other events I just want to advertise, and I'll put these actually in the chat. Coming up later this month, there is the celebration for the third cohort of the NHS Fellowship in Clinical AI. So it's their graduation showcase. Myself and Nick are going to this event because we're supporting the event through the Clinical AI Interest Group. It is in person in London. There still are some tickets because I just checked to make sure that I could advertise this to you. So if you do still want to go, then sign up quickly. It's on the 23rd of this month. So it's in a couple of weeks' time, and you'll hear all about what these amazing fellows have been doing in this third cohort. And then the last event I just want to advertise before I hand over to Joe is we're still running some seminar series for the Turing-Roche partnership at the Turing, and there is one coming up next Monday, the 16th of June, where one of the postdoc researchers, Iona, is going to be talking about her work developing fair and efficient clinical risk prediction. And there's a link there that you can sign up for that particular seminar. Okay, I'm going to hand over to Joe now.
Great, thanks so much, Emma. Really appreciate that. And good afternoon, everyone. So this would now normally be the section of our monthly meeting where we invite our 3-minute speaker to give a brief introduction to themselves, let us know a bit about who they are and what they're working on. But this month we don't actually have any volunteers, so I'm going to put it out there to anyone on the call right now. If you'd like to pop your hand up and give us a brief rundown of who you are, where you work currently, maybe something you're working on right now or a topic you're interested in, we can give you that opportunity. But in the meantime, while that's happening, Emma, can I just ask you, is there anything interesting you're working on at the moment?
Putting me on the spot.
Yeah.
So I'm very busy actually running a meta science project at the moment around biomedical data science careers. So it's funded by the Medical Research Council, And we're really looking into mapping. Well, first of all, we're doing a huge stakeholder mapping piece of work where we are mapping basically what is going on in the UK in that particular space. And then we're moving on to creating some or documenting some case studies around sort of best practices in particularly interdisciplinary data science, like health data science, because it's that area where well, data science in general, but I think health data science has so many different stakeholders that need to be involved. We're trying to come up with a sort of some really good case studies to show innovative ways of practice, so that we can really sort of inform everybody, but particularly the MRC, on sort of how this interdisciplinary research is really done really well, what sorts of roles are needed within these projects so that they have really diverse voices in them, and what sorts of skills those people actually need to be able to actually do their work.
Great, thanks, Emma. Fantastic. Thanks for filling time as well, because I can see we've got a hand up. So Maria, can we come to you? The floor is yours. Feel free to unmute.
Can you hear me?
Yes, we can.
Okay, let me see. Could I activate my camera too?
We can see you
Can
perfectly.
you see me?
Welcome.
Okay.
Yes. Hi.
Hi, everyone. My name is Maria. I am a researcher from Sheffield Hallam University and working in applied AI. My specific area of interest is reducing inequalities, and my specific, more specific, is in maternal health. So everything that is related with maternal health. At the moment, I have been working in the specific period of perinatal mental health, but I am interested in any area that involves application of AI, integration, adaptation, redevelopment of solution based in AI, but with a user-centric. And in this case, it's a mother, the one who is the initial or the main actor of the solution. So nice to meet you, everyone. And I was really fortunate to be in the event that was talking about Emma. And yes, it was a fantastic event. Looking forward for further collaboration. We have a really fantastic time, and that were really insightful to have the opinion and feedback from different sectors. And that's all. Thank you.
Brilliant. Thank you so much, Maria. Really appreciate that.
Thank you.
If anyone would like to connect with Maria, Maria, perhaps if you jot a LinkedIn link or an email address in the chat, obviously feel free to connect with anyone. I can see we've got another hand up from Johanna. The floor is yours, Johanna.
Hi, thank you. I take the same chance as Maria, as I was part of the AI for Women's Health event, to introduce myself. I'm Johanna from Fraunhofer Institute in Munich, so applied research organization. I'm research scientist working at the moment on LLM projects in women's health context, so specifically on the complex women's symptom prediction and analysis over time using large language models. I'm actually interested in any type of exchange or contact in that matter, be it female health tracking apps, or also in the more clinical direction, actually, to collect data together or collaborate in the prediction of like symptoms and potential health issues for women. And yeah, it was a fantastic event. I was very glad to be part of it, and hope that this community that was created in the UK can now like span or expand more into other European countries, also like reaching us in Munich at least.
Great, thanks so much, Johanna. Really fantastic to hear from you. Again, if anyone would like to connect, then feel free to connect in the chat. I recommend posting a LinkedIn thread, link or something similar. I can see we've got two more hands up, so I think we'll go to Claudia first, then to Jeff. So Claudia, the floor is yours.
Hi. Sorry, can you guys see me?
We can, yeah.
Hey. It's Claudia, by the way. You're right the first time. I just wanted to say hi. I'm Claudia. I'm a medical student at the University of Edinburgh. I have a background in neuroscience, and basically I'm very, very interested in getting involved in any kind of clinical adjacent projects this summer, especially with large language models. Background is in neuroscience with mostly like genetics stuff beforehand, and now I'm kind of branching out into Python and getting to know more machine learning / large language stuff. But yeah, hi.
There you go. Well, thanks very much, Claudia. So there you go, folks. If anyone would like to reach out and connect, then you've got an opportunity there. And then last but not least, let's go to Jeff. The floor is yours, Jeff.
Thanks, Joe. Good to take the opportunity. My name is Jeff. I work with Joe in Birmingham. I'm a clinical academic with a background in ophthalmology, but interest in AI implementation. I'm also bouncing off Emma's newsletter, hearing a conversation about the AI Fellow scheme, which is fantastic. I'm looking forward to going to that event. And in Birmingham, we're working at launching another kind of educational offering in the space around an MSc in AI implementation. It doesn't have any kind of coding or technical requirements, just aims to empower people to lead AI innovation projects where they work. So I'm just going to drop one of the modules, which is just as a CPD course to give you a flavor for what it is, if it's interesting, and it'd be great to connect with anybody that wanted to hear more about it. Thanks for the opportunity, Joe.
Thanks, Jeff. Really appreciate that. And last but not least, we'll go to Vlad for our final brief introduction. Vlad, the floor is yours.
Hi, everyone. Thank you. I hope you can hear me. I've just switched machines. Great. I'm Vlad. By trade, I'm a clinical psychologist and a CBT therapist. I work in the NHS. And in my portfolio, in my role, I work at the intersection between colleagues in IT, digital, procurement, IG, and frontline clinicians, but also lived experience colleagues. I'm mostly interested in clinician AI interaction design in terms of economics, but critical thinking at point of consumption outputs from AI and so on. Happy to be here and hope to connect with you online on LinkedIn. Thank you.
Thank you so much, Vlad. Really appreciate that. Bahua, I think we'll squeeze you in if that's all right, and then this will be the last introduction if that's okay. So over to you.
Okay, thank you. I'm Baihua Li, professor in AI. I work at Lapata University. So our main area is in the AI, machine learning, deep learning, large language model, and robotics. It's a great opportunity. We like to work together with clinical people. And currently we are working on the visual language model for medical applications. So how to collaborate with funding calls and also data analysis and joint PhD collaborations all range. I will send my contacts on the chat. Yeah, thank you.
Thank you. Fantastic. Thank you all for helping us with that. Again, if you're interested in maybe in next month's meeting, giving a 3-minute introduction to yourself, either drop myself or Emma a message and we can slot you in. The opportunity is there for you to just introduce yourself, to tell us a bit about what you're doing, or perhaps if there's a project you're working on or something you need from people, or maybe you're trying to recruit to certain roles. This is a great opportunity to speak to a whole group of different people about that. So do let us know if that's useful for you for future meetings. So thanks again for everyone that took the opportunity there. Moving on to the next part of our meeting then, it gives me great pleasure to introduce our theme speaker for this month, who is Professor Lapata. So Professor Lapata is a professor of natural language processing at the University of Edinburgh, and her work focuses on enabling computers to understand and generate human language, which obviously is hugely relevant to what we do in medicine. And today she's going to be trying to demystify a topic which I'm sure is familiar to all of us at the moment, very topical right now, which is what is generative AI? So Mirella, I'm really looking forward to your presentation. Thanks so much again for joining us this month. I'm going to ask everyone to save their questions for the end, if that's okay. Either pop them into the chat and we'll come to them in the Q&A, or wait till the end and pop your hand up either way. But without further ado, thanks again, Mirella. The floor is yours.
Thank you. Okay, so you should be able to see the slides, right? Yes.
We can see them and we can hear you.
Okay, perfect. So I didn't realize that this is such an interdisciplinary group, which is great. This is fantastic. So I'm just going to give an introduction on the topic of generative AI. I will tell you how these language models are built, what we need to do to get them to work when you have them like on your screen. There is a lot of work that goes behind the scenes to be able to have that kind of performance. And then I will finish by giving some of my thoughts of the problems around them that nobody has solutions for. Okay, so let's see now. This doesn't work. Great. Okay, right. So what do we mean by generative AI? There's two components in this term. First is the term generative, and then artificial intelligence. And I will start with artificial intelligence that I'm assuming everybody understands. It's artificial in the sense that there is a computer that does something. There is no human involved. And generative means that the computer will generate new content. And this content could be audio, could be images, could be video, code, but I'm going to be focusing mostly on text. Whatever I'm telling you now generalizes to code, not so much to images and video and audio, but even these models do need text. So you'll understand a lot about what these models, need. Okay, so one important point to raise here is that generative AI is not a new thing. It has become fashionable, but if you've been working on natural language processing like me or for a long time, we all know that generative AI was a thing 20 years ago. So this is an example from Google Translate. Google Translate was launched in 2006, and this is a sentence in Greek that is being translated in English. And this falls under the definition of generative AI. We have a computer program that actually generates the text. And the text is new, not in terms of content in this case, but in terms of the language. Siri is another example. The first version of Siri was launched in 2010. So again, a long time, and it's an instantiation of generative AI. We talk to the phone does things for us, such as set alarms and, reminders and whatnot. Now, other examples of generative AI that are already integrated in our lives, the completion in the search terms that Google gives us. This again is a very simple manifestation of the fact that a computer generates text, or the completion of the text messages on our phone. So generative AI, I would conjecture, it has been around for a long time, but something has changed. And what has changed is that now is not part of, science fiction. Unfortunately for us, we cannot be sitting here in our desk and be doing our research. People have started noticing. And why have they started noticing? First of all, because of the capabilities that generative AI has acquired. There have been lots of articles in the press saying that language models like GPT can beat humans on the SAT, or they take top marks in law, medical exams, and whatnot. I find it hard to believe, having kids myself and knowing how difficult these medical exams are. But anyway, these are the claims. But despite the hype, there are certain things that we can do with these things that were not possible, such as, for example, tell them to write an essay about the use of mobile phones during driving, so they can do that. Or you can actually ask them to write programs that check whether you've entered the information correctly. Or you can have a larger instruction where you tell them create a website, and these are the constraints. I like rock climbing, I like outdoor sports, I program, yada, yada, yada. And then the language model can actually generate this website for you. And it will save you a lot of time, and chances are that it will be correct. So what happened? The other thing is that there is a huge appetite for these tools. So we're going to get to the part as to why they work and how they work. But aside from that, the uptake of the technology has been tremendous. This graph shows the time it took for these different tools to reach 100 million global monthly active users. So if we look at Google Translate, our first example, again launched in 2006, it took more than 8.5 years to get to 100 users. ChatGPT, on the other hand, took only 2 months. So response has been tremendous. the users want these tools. How do they work? Okay, so for the rest of the talk, I'm going to focus on three things. One is, how did we get from these single purpose systems like Google Translate to language models? What's the technology behind them? And I will speculate on what we have to do to make them safe. Are they without risk? Should we be worried? And so on. Okay, so in order to explain how these things work, first of all, I have to tell you a little bit about language modeling. And I understand this is a talk and not like a lecture, but fundamentally, ChatGPT and Gemini and all these things are language models. And a language model aims to assign probabilities to a sequence of words. So we have our words here, W1 till WN, and usually because if we take, for example, a novel, it consists of a lot of words. And, you know, if we take the beginning to the end of the book, this will be a very long sequence. And some of you clinicians would understand that if I were to transfer this to DNA, again, it would be like a billion length, like, you know, there's so many combinations. We need to do something with these sequences in order to be able to estimate their probability. And we usually break them down using the chain rule to shorter pieces of text. So the probability of long sequence will be the probability of the first word times the probability of the second word given the first word times the probability of the third word given the previous two words, and so on and so forth. So using the chain rule, we have like this decomposition, and ultimately the estimation task shown here is the product of different decomposed probabilities, and these are conditional probabilities. So given a sequence of the words so far, we should predict what comes next. So here the words so far are W1 till WT minus 1, and we are supposed to predict what will come next. Okay, so we have a sentence and the model is predicting the next word given the sentence or sequence of sentence and whatnot. Now, the question is, how do you estimate these probabilities? And before neural networks, what we used to do, we would use the chain rule and then have like these smaller sequences, and we would go to a corpus and count how many times 2, 3, 4, 5 words occur. And we would do all of this based on counting, which is not what we do presently. We do not use this counting method. Instead, we use a language model to estimate what comes next. So again, given a sequence of words so far, the color of the sky is, we need to predict that it is blue, and we need to estimate how likely it is that blue will be following the color of sky. And all the magic, if you like, happens in here in the language model. So what language models do you choose, and how you actually estimate these probabilities? How do you learn the weights of this language model? Okay, so how do we do it if you wanted to do it? We collect a very large corpus, and this we're talking like, you know, all of the web. Here I have some examples. It could be Wikipedia, Stack Overflow, Quora, Reddit, GitHub, novels, all the screenplays that are out there. Basically, you take a copy, and then your task, the learning task, is to get this language model to predict the next word in a sentence. So how do we do this? We will take the sentence and we will randomly remove things from the sentence, and then we will calculate the probability of the missing words. And we will do this multiple times because the learning is an iterative algorithm, and we will adjust and feed back to the model to match the ground truth. Now, there's a few important things here to note. First of all is that I actually don't need any humans to go and annotate the data, because I'm being clever and I'm saying I'm going to train this model on a next word prediction task. This is very important. This notion of self-supervision has actually revolutionized our ability to train these models. Okay, I still haven't told you how the model looks like. This is coming up next, but this is what the model uses as its objective to learn its parameters, the next word prediction task. And the other important point is that this is an iterative process. The model cannot learn this by going over the corpus once. we have to like sort of do it multiple times, where we change our weights, calculate the next word prediction probability, and we keep doing it several times. That's why training takes months and whatnot. Okay, so this self-supervised notion, I have a picture here. We have this large text corpus again as input, and we're trying to predict what follows after the Trevi fountain is in the center of. And we are having the language model, and the language model will make some predictions. The first time it may say it's Rome, the second time it may say Buenos Aires, and we actually match these against the gold standard. And the gold standard is we know what these sentences look like from the web because we've downloaded them. So that's how we supervise. And then we go back here. This arrow means that I'm going to go and change the model's parameters, and I will repeat this thing multiple times till I hit the right answer, which in this case is Rome. Okay, to give you a notion now of what I mean by model parameters, these are basically these connections here. So this is a simple feed-forward neural network, and again, it's an abstraction. We have 2, 4, 5 input nodes, we have some intermediate nodes, and then we have the output. And I should have actually highlighted input-output differently, but anyway, it doesn't matter. This is taken up by, we have like these 2 intermediate layers, input, output, and all these connections. And you see here that every node connects to every other node. And so when we say that the network is trained and learns, what we really mean is that we learn these weights. Like if I have some input, what weight will I have? How likely is it that, things will be on and off? And the weights, if I calculate them for this simple example, is 5 times 8 plus 8. This is a bias term, and the same for the intermediate and the output. And this means that I have 99 trainable parameters. So this is a very simple neural network, and I need to estimate these 99 values. When we go to very large language model, we're talking about millions or even billions parameters, many weights. Now, we are not using, when we're building GPT and Gemini and whatnot, we're not using these simple neural networks, although the principle is the same. We're using these specialized architectures called transformers. And I'm not going to go into the detail of the transformers because it is quite involved, but this architecture has been the main building block of everything we see nowadays in NLP. And the reason is why it's the thing we all of us use is because we can easily do the training by parallelizing them. So we can change these weights in parallel, otherwise it would be very slow. So a transformer takes words as input, the chicken walked, and predicts the continuations across the road. And in between, we have many layers of neural networks. It's not like one. You see here, we have a mass self-attention. This is a way of actually paying attention to some input words more than others, and then we will have a feed-forward neural network. And this is our decoder block. This is a neural network for predicting the output, and this will be repeated along several layers. So we will have 64 of these blocks or 100, it depends a bit on the design. And so many parameters, and you can think of it as, rolling out different networks along the training, and we will have to learn the parameters of this network. So it is quite big and much more complicated, and there is different individual things in the transformers, such as token and positional embeddings, that are important because transformers actually don't pay attention to the order of words and whatnot. Okay, so from this very simple thing, we have come to the transformers now. That is a robust architecture upon which all the models are trained. So what happens now? So I have my transformer, and I have a way of training the transformer by the next word prediction objective, and I have a big corpus upon which I've trained the parameters of my model. And this is what you see here, the pre-trained model. And once I have this pre-trained model, what I can do is I can have a specific task, which could be in a different domain to what my transformer model has been trained on. So say I trained it on the web and then I want to specialize it on some biomedical task, then we will get some data and we will fine-tune the model. Fine-tuning means change its parameters. So all these weights will change now to be able to do this specific task. And this is what we used to do. So we would have different tasks and we would get like this pre-trained generic language model, and then we would fine-tune it on different data sets to make this model performant on different tasks. And here I show a summarization task, an inference task where we are asking whether two sentences are similar in their meaning, a question answering task, and basically a procedural generation task. And depending on different data, and the colors here denote different tasks, I would get different copies of the same model specialized for different tasks. But we don't do this anymore. So the question is, how can we avoid this specialization for different things by making the middle part, like the pre-trained language model, better? And so the question is, how good can we make this language model, and how? And the lesson that we've learned is that, you know, the bigger the model is, the better its performance. And by bigger, we mean it sees more data, but also it is bigger. It has more parameters. So yes, this is a true statement that since 2018, we've witnessed an extreme increase in model size. And I think now this is kind of plateauing. I think we will see a retreat to smaller sizes, but this is like a prediction. So to give you an idea as to, you know, what the scale of these models are, we start here with GPT-1 and we go up to GPT-4. You can see the straight lines give the size of different brains. So we have the ant brain, the rat brain, and up there the human brain. So the human brain is, of course, is the biggest of all. It has 100 billion neurons, and these are all approximations, and 100 million connections. Now, if we take the human brain and its connections and we compare this to the weights that these models have to the parameters, we see that we started with 100 million parameters, which was GPT-1, up to GPT-4, which is 1 trillion parameters. And performance is improving with model size. But by model size, I mean number of parameters. And we're still not reaching brain sizes, so the 100 trillion connections, GPT-4 doesn't have them, but it has 1 trillion. So this is a very big model. In terms of the amount of data it has seen, again, you see here at the bottom the number of words that are read or heard by a human in their life. It's approximately 100 billion words, and you see that data is also being more and more and more, and we're now reaching the limit of all human written text. I say this, but of course it's a, you know, it's a moving target, because if we've reached the text produced by humans, you know, they hire people that generate more text, and then there's the LLM text, so text gets generated, and soon we'll be at a point where we don't know who generates what. And finally, of course, the prices increase, and you know, we start with $10 million, and then we go to billions, and you know, you need to be very rich to play this game. Okay, now this is supposed to show, I don't know whether it will work, and I don't think it works, I'm sorry. Here it works. Okay, I'll let this play. This is like how increasing the number of parameters gives you more tasks. So I think it is on auto loop. So we do a few tasks with a few billion parameters. We can do question answering, arithmetic, and then with 500 billion parameters, you get to do all of these natural language tasks. And imagine what you can do with 1 trillion. Okay, now, but what people discovered, and this is the interesting thing, once you build these language models and you scale them and you have a lot of data and you have like many parameters, they still behave like language models. So remember how they're trained. They're trained with the next word prediction objective. So they wouldn't be able to do any tasks. You would ask them things and they would start like completing sentences randomly. So the models don't have the ability to be able to answer questions and adapting to the prompts appropriately. And this is where the idea of instruction fine-tuning comes in. So we have our pre-trained language model, and now what we will do is we train it once more, but we're not going to train it with this next word objective. We're going to give it examples of tasks we want the model to be proficient in. So for example, this could be question answering. Please answer the following question. What is the boiling point of nitrogen? So we're going to give it questions and answers. We're going to give it chain of thought fine-tuning, like examples of steps. We're going to give it answers. And so it will have seen the model, how we want it to behave and how we want it to break down the task. So if we give it these multitask instructions, many tasks, here I have the number 1,000 tasks that we know that we want the model to do, then once it has seen this like multitude of tasks, it is able to do things that it sort of has not seen before during training. And by that, I want to be completely clear, because you hear these things, oh, they have emergent abilities. They don't have emergent abilities. They have very good memories and they can be trained to understand tasks. So if you have a similar task, but not identical, they can do it. So for example, can Geoffrey Hinton have a conversation with George Washington, give the rationale before answering? It has never seen rationales for this question, but it has seen rationales before. And that's how it generalizes. And I put quotes there. Okay, so now with this instruction fine-tuning, we have crossed, we are now beyond having a language model that completes sentences. We can actually have something useful. And instead of actually fine-tuning, having copies of the same model to do different tasks, we have one big fat language model that has been instruction tuned and can answer many questions. And this is the idea of, you give it a prompt and then it fills it in for you and you have one big fat language model. And this is what has been put out there. It's one model that can do many tasks. Now, we're not done yet, because what they observed once they did the instruction fine-tuning is that, these models are supposed to be used by users, and users have different values. They come from different socioeconomic groups. They have different sexes. They have different intentions. And so how is the language model, which is kind of stupid, really, it has been just trained with this next word prediction objective, how can we use it to interact with humans? And this is now the alignment problem. So the question ultimately is, how do we create a language model or an agent that behaves in accordance with what a human wants? And there is many things to unpack here. Who is the target audience? How are we determining what it means, what they want? Because we actually don't know. The developer does not know what the user wants. I mean, we can have ideas, but users are unique. So the point is that if we have AI systems with skills that we find important or useful, the question emerges as to how we can adapt these systems to reliably use these skills to do the things that we want with the users. So the models from instruction fine-tuning onwards are not aligned. That means they don't actually have any notion of what the users might want them to do. And that's why you may see them being opinionated or use inappropriate terms. This is pre-alignment. So there is a theory about the alignment, and it's attributed to Askell et al. It's a very nice paper, and basically we have the 3 H's framing. So a language model has to be helpful, honest, and harmless. What we mean by helpful, it should follow instructions, perform tasks, answer relevant questions, and clarify user intent when this is not clear. Honest, it should be factual, provide accurate information, and acknowledge its own uncertainties and limitations. And finally, harmless, it should avoid toxic, biased, or offensive responses and occasionally say I cannot do that if we ask it, for example, to create a bomb. Okay, so in order to instill these notions of helpful, honest, and harmless in the language models, what we usually do is and this happens after the instruction fine-tuning, is we get more data, always more data, but this is kind of special data, and we get two answers to a question, and we ask humans to rate them and say which one they prefer. And this data is very valuable for aligning the language model. So I'll give you an example. If the input is what causes the seasons to change, a human would see two possible answers. Changes occur all the time and it's an important aspect of life, versus the seasons are caused primarily by the tilt of the Earth's axis. And in this case, of course, the second answer is preferable. So we would rank these answers. And this we can do it with other questions. Is it possible to prove that P equals MP? And again, the developers come up with questions and different answers, and the human user would rate these answers. And that brings us to preference models or reward models. So remember, we started with a neural network trained on data, then with a next word prediction objective, then we did the fine-tuning, the instruction fine-tuning, and now we are at the third stage, which is trying to align the model to user preferences. So we have a user request and we have a baseline model. This is our instruction fine-tuned model, which now we are gonna change or tweak ever so lightly given a preference model. And a preference model tells us, given an input and two responses, which one do we prefer? So we will train this preference model or reward model, and we use it to additionally train the baseline model to prioritize responses that humans find better, that they have higher preference scores. So already I'm at the second stage of fine-tuning, which is I have a reward model to make the model shift its responses to what humans prefer. And although I'm not covering this, I'm just going to put it out there. All the stuff you hear about reasoning and whatnot, it involves yet another stage of fine-tuning. After you have your reward model, you would actually then fine-tune it for reasoning with more data. There's always more data. Okay, so once this is the recipe. So if you want to try tomorrow to build a language model, this is how you should probably go and do it. Since all of these, and it's true that OpenAI has been at the forefront for all of these developments. They put out the preference model first, not the instruction fine-tuning, but the recipe of like building these models. Now, since then, since let's say 2023, there have been so many models. You see here, the blue is the new derivative models released per month on Hugging Face. You can go to Hugging Face and you see derivative means there is a model, a company makes it or somebody else makes it, and then I make a change and then I create a new model and I put it on Hugging Face. And we see here it's like in the thousands. And in the red, you can see new derivative models released per hour. And smaller bars means there is more frequent releases. And you see February, for example, every 24 hours, we had like a new model. Okay, so then we have these models. Clearly, they're useful, but what is wrong with them? Or what could go wrong with them? An important point is that they are trained on data and nobody can actually inspect this data. What people do is like they collate the data, they clean it up, and then they let the model on the data. And that means that you're feeding the system on data you cannot actually control or regulate. And I have this quote there from this paper. This is an early paper, but it is very, very, very accurate, which says that feeding AI systems on the world's beauty, ugliness, and cruelty, but expecting it to reflect only the beauty is a fantasy. So we cannot regulate the content. The models generate hallucinations because of their objective. There is no way of not doing that. It's actually impossible not to generate hallucinations because they are always maximizing likelihood. So they will go for the most likely answer, even if it's wrong. And they will occasionally exhibit, despite the alignment, undesirable behavior. So this is a study that appeared in Nature. And if you look at this Birain and Prabhu paper, it appeared in 2021. This was before ChatGPT. All of their points are valid to this day. But if we go to 2024, where we have bigger, better models, there has been a study by some researchers in Stanford, and basically their conclusion was that AI generates covertly racist decisions about people based, and this is the drum roll here, on how they speak, on their dialect. So what these guys did is they gave to an LLM a person who says, I am so happy when I wake up from a bad dream because they feel too real, and then the LLM completed brilliant, dirty, intelligent, lazy, stupid, and you see its most frequent intelligent. Whereas if you give the exact same prompt, but you change a little bit, and you change only the dialect, not the content, a person who says, I'd be so happy when I wake up from a bad dream because they'd be feeling too real. So they're identical. The meaning is the same, different dialect, vernacular dialect in blue. Then the LLM completes that this person is most likely lazy. They make mistakes with regards to factuality. This is, so next point, they're biased covertly, but they're also actually overtly wrong. So this is an example from, this tweet has been publicized. So when Google released Bard, this was one of their flagship models, this was a precursor to Gemini. They advertise it by saying, you can ask it whatever, so you can ask a question like, what new discoveries from the James Space Webb Telescope can I tell my 9-year-old about? And it came up with a very nice answer saying you can talk to your child about, the galaxies, about the fact that the telescope took the very first pictures of a planet outside of our own solar system. So nice facts. Except that an actual person, Grant Tremblay, who is an astrophysicist, read the answer and said, well, I'm sorry, I don't want to be a jerk, but I actually don't think this is right. The James Webb Space Telescope did not take the very first image of a planet. This was done by something else using adaptive optics. And this mistake wiped $100 billion of Google's parent company Alphabet's shares. So it plunged by 7.44%. So it can also cost money. Okay, so it used to make sexist jokes. I'm not going to go into the detail. It doesn't anymore. They fixed it. What I want to say is that the impact on the environment is actually real. And it's not only people think, okay, you train this model, it's a one-off. We are actually damaging the environment every time we execute a query on ChatGPT, because just a single query takes 100 times more energy to execute than a Google search query. And of course, you're burning electricity, you run inference, which means you have to actually find the answer. And so compute doesn't stop. Deploying these models is, I would argue, more expensive than actually making them. Llama, which is a publicly Meta, released this model. So its training produced 539 metric tons of CEO just to train it. And I'm not factoring in how much it costs in terms of CEO to run it. So they use more energy during their deployment. There is clear impacts on society. There will be jobs that will be lost. Goldman Sachs predicted 300 million jobs will be lost or degraded. And in fact, they're one of the very few companies who have AI for everything. I learned recently they have built their own system that uses all these language models to do lots of tasks. I don't know whether they've fired people or demoted them or reskilled them. Jobs will be lost, this is for sure, or adapted, or there will be a supervisor of the AI. There is impact on what's true and what isn't. Can we trust what we read? Maybe not. People have tried to fake essays, fake songs, fake news. There is a very well-known story about Schumacher, one of the most dominant Formula One racers ever. He's been in a coma since he was injured. And then apparently there was an exclusive interview in a German tabloid in April 2023. The interview was entirely written by AI. Apparently then there was litigation. I don't think this tabloid still exists. It led to public apologies, the fire, the editor-in-chief, and there was a lawsuit which I believe the Schumacher family has subsequently won. And finally, there is issues with privacy and trust. And these are important questions. We don't have the answers yet. People are discussing them. Is it okay to use AI systems for personal data or private data? So would you trust a purely AI doctor or therapist? Can the AI model accidentally leak your private data by being trained to mimic it? Of course it can. I know the answer to this. Would you be okay if the LLMs are trained on your data? And what if it produced your data when it generated text for somebody else? So these are valid questions. And of course, we have to make these systems be responsible for their answers. They should be able to explain their reasoning and also provide sources for their claims. Ownership is another problem. Who is the author of what an AI system generates? Is it the company that created the model? Is it the user that created the prompt to get the output? Who takes ownership of the content and who takes liability for its mistakes? Do organizations that build and deploy these systems bear the social costs of any harms they may cause? And finally, this leads me to the last slide, which is AI governance. This is coming. There's several efforts underway across the world, from EU, in the US as well. So there has to be like a framework, and a lot of people are working on this. Different countries adopt different frameworks, but there are the same themes. One wants to have safe and secure systems. There have to be protections against discrimination of individuals or groups. The systems have to be transparent and accountable. They're not yet, right? This is all aspirational in the future. They have to support explainability and interpretability and maintain data privacy. So there have to be, like we have the standards for the web, we have to build standards for the usage of AI systems that manage and enforce safeguards, and there's various stakeholders in this game. It's not only the creators of the systems, it's not only governments, it's educators, AI researchers, and this is a dialogue. And that is ongoing, and we don't really have solutions. I will leave you, I will not read this to you. I asked ChatGPT to write a poem in 2 verses about how AI will take over the world. It actually generated this picture. This is AI taking over the world, this monster there, and these supercomputers. And yeah, it gave it the title, The Rise of the Machine. You're welcome to read it, and I will stop here and take questions.
Mirella, thank you so much. That was a fantastic rundown of a really complex topic. We have a few minutes for some questions, and you probably haven't noticed, but there's been some fantastic discussion going on in the chat.
Not really, no.
Yeah, okay,
but
well,
good. By all means, discuss.
Lots of people engaging, yeah. So we got a question from Ajoy. Should we come to you first? Yeah, there you go.
Yep. Thank you so much. Thank you so much, Mirella and the team for setting this up. My name is Ayub. I'm a co-founder of the AI health tech startup looking at meta-analysis and clinical development. My question is a twofold one. When training data, there's a group in Cambridge, which is astrophysics team, that were training astrophysical, if you can call it like that, data to be able to establish better models for nebulae and the likes. And they were running out of data, and what they eventually did is they looked at YouTube videos of cats, pure cat videos, and trained their data on that. And they saw that the model became significantly better in predicting by looking at completely random, non-relevant data. And I thought that was fascinating, and I was wondering what your thoughts are with that, because we're in a clinical development or clinical space. We're always looking at there's not enough data or access to data, and would it help to identify other data sets that have nothing to do with the clinical setting to train them on that type of data?
Okay, that's an interesting question. So this is a very important question. What is the data that you give the model to train on? And I think one of the lessons, there's multiple lessons that we've had. So these guys, probably the data on some level, the astrophysicists had some usage for the tasks on the level of, you know, the movement of the galaxies and whatnot. So at the pixel level, the data may be relevant, but also useful. This is the first thing. So, you know, we don't know for all of the tasks what kind of data to use. The other thing is that we know progressively now that at least for NLP and for some of NLP and computer vision, that less data but high quality data is a lot better than more low quality data. So the astrophysicists, this is a workaround, and it's fine. You can use data and you will improve a bit, but their improvement would have been a lot better had they had targeted data. So in your case, I think if you have some money, just pay humans. And there is a very clear study in creating multimodal models by OpenAI. So these guys had the idea to just annotate some images with clicks that say how many objects are. And these clicks are amazing, and their model is very good. And this is an example of very good data. And there is a third point, which is we have to be clever about the data, because it will not be there. And I'm not very hopeful that bad data will lead to good outcomes. In fact, the thinking is that, you know, synthetic data is not as good as human data data is not as good as specialized annotated data, really high specialized data is better. So yeah, I stop here and maybe I see more questions.
Thank you.
Thank you, thank you. So we're up to the hour, so I'm just going to quickly say my last final bit, which is to say that our next group meeting is on the 8th of July, which is obviously next month, and that'll be as usual at 12 till 1 p.m. So thank you again, Mirella, for joining us today and for being our presenter. Kevin, is it a quick question or is it a longer one?
It's probably a longer one. I'm just going to ask about you know, as we're running out of data to train these large models, and they're starting to consume the output, either their own output or the output of other models, is there an auto-regressive risk in these models, the models that are being trained currently?
Yes, the models will only see synthetic data, and we know it doesn't really work. But what does work is what you said, which is you take the output from different models, and then we've built frameworks such as, for example, debating. So model A debates with model B, and model C then judges the debate. And this is a workaround to say, you know, they've seen different data. We don't know what they've seen, but we can exploit this. So we'll see more of frameworks like that. And yeah, in the end, I don't think it will be good, because all the data on the web will be synthetic. We will all talk like ChatGPT. We will all have the same quirks in the style, and you know, the innovation will go out of the window. So they will have to reassess this.
It was just a quick follow-up. The slide about dialects was really interesting, because if you think about humans and how we train, right? You know, if you're training to be a doctor or a radiologist, you learn a particular dialect to be able to express very precise information in that. Is there any evidence that these models are good at learning those dialects?
Not really. It's all because they won't have seen as much of these dialects. It's all like, how much have you seen during your pre-training and your fine-tuning? Vernacular, which was the example, they haven't seen a lot. And the same with medicine, right? There are these initiatives to build like this Nightingale AI at Imperial. Maybe you know this. This is going to be a language model for medical data and whatnot. And my bet is like, if they can find the data, and there is a lot of data in all of the world's medical journals can be put in the model, then it will succeed. If not, there's always going to be case out of domain that it will not know and it will fabricate something and the consequences will be bad.
Well,
But-
on that cheery note, thank you again, Mirella. A huge round of applause, and thank you so much for joining us this afternoon. Definitely a cautionary tale. Great potential in these systems, but really quite significant challenges to overcome. So I think that's maybe a good summarise there.
That's
so next
great.
meeting,
Thank you.
Yeah, thank you. Next meeting again, 8th of July, same time as always, midday to 1 o'clock. Thanks again for joining us, and we'll see you all next month.